right, let's take a look at chemistry. Whoa, chemistry. I thought this was a biology class. Well, we shall see. All right, the composition of matter. Let's begin with some basics here. Matter, everything in the universe is composed of matter. And that matter being anything that occupies space or has mass. So when we talk about the mass of something, we're not talking about its weight. Remember, weight is related to gravity. But the mass is the quantity of matter an object has. So my mass, the amount of matter in me, is the same whether we're here on the earth or on the moon. Regardless of the amount of gravity, my mass would stay the same. Okay, so let's look at the elements. Here is the periodic table, and we'll spend a little more time with that. I'll teach you how to use it. But when we look at elements, they are defined as pure substances that cannot be broken down chemically into simpler kinds of matter. They can't be broken down by ordinary chemical means. And there are more than 100 elements. 92 of them occur naturally. Now this CHNOPS, these are the most abundant elements, and that would be carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. Okay, let's take a look at the atom. Here's a picture of the atom. Here's the nucleus. Here are these energy levels. They're also called shells. You'll hear them referred to them as valence shells. You'll hear them called orbitals. All of those mean the same thing. It's all the place where the electrons are. The nucleus is the site for the protons and the neutrons, and then out in the shells are where the electrons are. Okay, some basic properties of atoms. It's those properties that determine the structure and properties of the matter that they compose. So here's our nucleus. In the nucleus, we have positive charged protons and neutral neutrons. So neutrons have no charge. Protons have a positive charge. So remember it that way: proton positive, pp, neutron neutral. So look at neutral neutrons. And you have this positively charged, and it can, because there's positives in there and the neutrons with no charge. So the nucleus is going to be positively charged. And it's here that in the nucleus contains most of the mass of the atom. Remember, that's the amount of matter, and most of that is taking place in the nucleus. All right, so let's take a look at these protons. All atoms of a given element have the same number of protons. So here's this great little picture here. You have an oxygen atom, all right? And this 8 up here tells you the atomic number of oxygen. The atomic number is the number of protons. So you just have to memorize that. Atomic number is the number of protons. Now, when it says the number of protons, that in a neutral atom, the number of protons is going to equal the number of electrons. They are going to have the same number of protons and electrons in a neutral atom. Now, in this case, it shows that there's 8 neutrons, but that's not always the case. The number of neutrons can vary significantly, but remember, the protons and the electrons are going to match each other in a neutral atom. And again, like I said, this number right here is called the atomic number. That is the number of protons. This is very important because it's this atomic number that determines which element we're talking about. The number of electrons can change, the number of neutrons can change, and that's fine. That means different things, but the number of protons cannot change. If the atomic number or the number of protons, if that changes, we're talking about a whole different element. We cannot. What defines oxygen as oxygen is the 8 protons that it has. All right, and like I said before, protons equals electrons. So a proton is balanced by an equal number of negatively charged electrons. Electrons have a negative charge. Remember we said that the nucleus has a positive charge because the proteins are in the nucleus, and the electrons are outside in those shells. So that is the, and it's got a negative charge to the electrons. Excuse me. The neutrons, the number varies slightly among atoms of the same element. So we still have carbon because there is, carbon is defined by having 6 protons. So if it has 6 protons, it has to have 6 electrons in a neutral atom. All right, so notice each one of these, whether it's carbon 12, carbon 13, or carbon 14, you have 6 protons, 6 protons, 6 protons, 6 electrons, 6 electrons, 6 electrons. So your protons are going to equal your electrons. We're keeping it a carbon, so we keep that, our atomic number, the same, but our neutrons can vary. When the neutrons are different, these are called isotopes. So you can have different isotopes of carbon, and typically when you have your isotopes, you have radioactive isotopes. So you can see the carbon 12 is non-radioactive, carbon 13 is non-radioactive, but when we get to carbon 14, that's radioactive carbon. All right, so here you have, we have the same number. So the reason why it's called carbon 12 is the mass number, the total mass is determined by protons plus neutrons. Most of the mass, remember, is in there in the nucleus. The mass of the electrons is so negligible that in chemical reactions, it doesn't have that significant of an effect. So we don't include the electrons when we look at the mass number. There's such a small number. It doesn't mean that they're insignificant, but it's just not, it doesn't have that big of an effect on the actual atom. All right, so carbon 12, so the 12 comes from 6 protons plus 6 neutrons, because we're talking about the mass number. In the isotope carbon 13, we have 6 protons, of course, because those can't change, but we have 7 neutrons. So now we have an extra neutron. Doesn't change the charge, because remember, it's neutral. Those neutrons are neutral, so they're not having any impact on the charge, but they are having an impact on the mass number. And then radioactive carbon 14, we're all the way up to 8 neutrons there. So we're still at our 6 protons, otherwise we wouldn't have carbon anymore. But now we have 8 neutrons. All right, and just like I said, different number of neutrons produce isotopes of the same element. Let's go back to atomic mass. Protons and neutrons are found in the nucleus of the atom. We know that. Protons and neutrons each have a mass of 1 AMU, which is an atomic mass unit. And the atomic mass is found by adding the number of protons and neutrons in that atom. Okay, so that's atomic mass. So let's go back here for a second. Atomic number, number of protons. Atomic mass is the number of protons and neutrons that are in the nucleus. Moving on to the electrons. All right, so the red and blue in here is our nucleus. So that's our protons and our neutrons. And then the electrons are these negatively charged high energy particles that have little or no mass. They have very little mass to them. They travel at very high speeds at different distances, or the energy levels, like I said, they could be called orbitals, they could be called valences, but they're different distances from this nucleus. Electrons in the same energy level are about the same distance from the nucleus. So if they're in the first energy level, then they're in this, what we could call it as a ring, in that first ring. The outer energy levels have more energy than the inner ones, and each level only holds a certain number of electrons. So your first orbital here is going to hold 2. Your next one is going to hold 8. The next one after that would hold 8 more, and so on and so forth. All right, let's look at compounds. Compounds are where you have two or more elements that are bonded together. Two or more different elements that are bonded together gives you a compound. Very much like when we talked about the compound light microscope. It was called the compound light microscope because it's compounding the image from the ocular lens and the objective lens. So two different lenses together give you that compounded image. Well, in a compound, you have two different elements that bond together. The tendency of elements to combine and form these compounds depends on the number of arrangements of these electrons out here. Here's our protons and neutrons in the center, and the outermost shells, what's going on here with the electrons. These atoms are most stable when their outermost energy level is filled. So when that is filled with 8 in its outer shell, it's happy, it's stable, it doesn't react, it doesn't need to find anything, it doesn't need to get rid of anything, doesn't need to share anything. It is happy. But most of them are not stable in their natural state, and they tend to combine or react with other atoms, and they undergo these chemical reactions. In the chemical reactions, the bonds are broken, atoms are rearranged, and new chemical bonds are formed, and those are going to store energy. And it's in the bonds are when energy is formed. When the bonds are broken, then the energy is released. All right, the three types of bonds, there's more than that, but the three main ones that we'll talk about. Covalent bonds, where these outer electrons are shared. Ionic bonds, where you will donate or gain, you will lose or gain an electron. And you also have what's called hydrogen bonds, which are really important when we talk about water. That's all we're going to go into now. I'm going to go into some more detail and some more activities that we'll use in class when we talk about the bonding of these with the covalent, ionic, and hydrogen. That's all we have for today, and have a marvelous evening.